8, Unit 9, Lesson 3, Part 2. We're continuing with the quotient rules for exponents. These are just going to be a bunch of examples that follows up the previous video. Okay, simplify the expression, write your answers as a power. All right, 9 to the 7th over 9 to the 4th. Because they have the same base, we can subtract the exponents, top minus bottom, and you get 9 thirds, 9 to the third power. Okay, number 2, because they have the same base, 4.2, we can subtract their exponents. 6 minus 5 is 1. So this is just 4.2 to the first power. You don't actually need the exponent when it's a 1. Number 3, because they have the same base, we can subtract their exponents. 8 minus 4 is 4. We get negative 8 to the 4th power. Number 4, because they have the same base, we can subtract their exponents. 8 minus 3 is 5. We get x to the 5th. Next example, x to the 41st over x to the 15th. Because they have the same base, we can subtract the exponents. And we get x to the 26th. Okay, these are all the same base. When they are multiplied together, you add the exponents. So this is 4 plus 2, which is 6. When they are divided, you subtract the exponents. So this would be 6 minus 3, which is 3. This is 3 to the third. Now this can be done another way. We could have done the 3 to the 4th over 3 to the third first. And if you do that, you get 4 minus 3 is 1. 3 to the first times 3 squared, that's 1 plus 2, which is 3. You get the same answer. Okay, a to the 10th over a to the 6th times a to the 7th over a to the 4th. Write your answer as a power. This also can be done a couple of different ways. So let's actually go over both of those. One of them, let's divide first. So a to the 10th over a to the 6th, 10 minus 6 is 4. A to the 7th over a to the 4th is 7 minus 4 is 3. It'd be a to the 3rd. And then we can add 4 and 3 and we get a to the 7th. Okay, the other way this could be done is let's multiply first. A to the 10th times a to the 7th, 10 plus 7 is 17. A to the 6th times a to the 4th is a to the 10th. 17 minus 10, 17 minus 10, it would give us a to the 7th. We get the same answer either way here. Basically what's happening, everything that's being multiplied would be added, and everything that is being divided would be subtracted. And if you figure this out, it comes out to be 7. So it is a to the 7th. Okay, simplify these expressions. Everything is the same base. Let's go ahead and combine these together on bottom. Since they are being multiplied, 3 and 5, we can add them and get 2 to the 8th. So this is 2 to the 15th over 2 to the 8th. 15 minus 8 is 7. We get 2 to the 7th as our answer. Number 6. D to the 5th over D. Let's go ahead and reduce that. 5 minus 1 is 4. 9 minus 8 is 1. This is d to the 4th times d to the 1st is d to the 5th. 4 plus 1 is 5. Okay, 5. I'm going to do this one multiplying across first. 5 to the 9th times 5 to the 5th would be 5 to the 14th. 9 plus 5 is 14. 4 and 2 make 6, so this is 5 to the 6th. Then I need to do 14 minus 6, that would be 8. 5 to the 8th power is the answer there. Okay, this is about as complicated looking as it will get. And what you want to do if there's multiple things, and you'll have some examples of this in your practice, and at least one like this on the test, you want to cut it up into its pieces. So 36 over 16, we've got j to the cube, j to the 6th over j to the 3rd, and k to the 11th over k to the 10th. So we're going to simplify each of these parts separately. Now, common mistake might happen here on the first section. Those are just regular numbers. That's a regular fraction. So we are just reducing 36 over 16. Well, 36 is what is it, 4 times 9, and this is 4 times 4. So we can reduce by 4s, and we get 9/4. Okay, for the j's, since they have the same base, j to the 6th over j to the 3rd is j to the 3rd. All right, k to the 11th over k to the 10th is k to the 1st. No need to write the exponent on there. So this answer would be 9/4 j cubed k. It also could be written as 9j cubed k all over 4. Both of those are correct, and both of them mean the same thing. Okay, looking for some common mistakes that happen with these types of problems. X to the 6th minus x squared. Now this is actually more of a 7th grade problem where you add like terms. These are not like terms, so nothing happens. Common mistake students would make, though, is to go ahead and subtract the exponents. That does not work. The correct answer is you can't do anything. It's already simplified. Okay, the next one. 6x to the 11th over 3x to the 4th. Common mistake here is not only did they subtract 11 minus 7 to get 11 minus 4 to get 7, but they decided to do 6 minus 3 to get 3. Now, you don't subtract here. You need to divide those, because those are just like a regular number. It's 6 over 3. You just get 2. 6 divided by 3 is 2. Another common mistake is like this x to the 21st over x, just saying, hey, it's just x to the 21st. But the mistake that happens there is not realizing that the x on the bottom, because it doesn't have an exponent written, it's basically an exponent of 1. And you would do 21 minus 1 and get x to the 20th. Okay, the assignment on this. Number 1, you're going to simplify the expressions. Number 2, just these are more examples of what we had there in the notes. You simplify the expressions. Number 3, you're going to graph the two equations and solve, or you can solve using the transitive property. There's 2 options. Number 4 is a problem where you manipulate an equation to see if Jeff is correct. Number 5, you're going to do a translation. Number 6, you're going to find the area of the square. Number 7 is and number 8 are situation problems dealing with exponents. Thanks for watching.